Hello my friends, and welcome back to the Signal State. We are here again on Tractor Gear System. You may notice things look a little bit different up here in this region. When last we left, we were struggling to figure out how to alternate the output on, off, on, off. We can't have a clock with a signal that long, so we were trying to figure out how to flip it back and forth, and getting absolutely nowhere. So I banged my head against a wall for another hour or so after the end of the last episode, got absolutely nowhere. I decided to take a little trip over to the Steam forums and see, not necessarily if I could find a solution, but if there were any hints as to what is the right way to approach this. And I did find a hint that suggested using 2 of these sample and holds. The idea being that one of them will hold the on state, the other will have the other will hold the off state, and then by triggering them, you can have them switch every time, and then that is the output you take. So I messed around with that back and forth, and I came up with this here. So as you can see, we know that. So to explain what's going on here, we have our clock 4 interval. This will pulse at time step 1, 5, 9, every time that this needs to switch, this pulses. So we take that and we send it to a sample and hold as the gate, right? So we want to, so this sample and hold will sample every time it needs to flip. That's fair enough. Here, we invert that clock signal and send it to this sample and hold. What that will do is, instead of having the gate be open on the first tick and then closed for 3, and then open and then closed for 3, this one will work the other way around, where it will be closed on the first tick and then open for 3. Now that's a little counterintuitive. Why would we want that? Well, what this actually does then is, on the first cycle it's a little messed up because it's closed on the first one, so this will just be 0. But then the second time we get to the point where it turns off, it basically remembers the output of the previous sample and hold from the previous step. It's a little confusing, but basically what this ends up doing is, every time this second sample and hold pulses, the current output value gets sent to this sample and hold, and then the second one flips. And so by doing that the first time through, let's see if I can actually, let's turn this, well, I don't need to change that. Let's just step forward. So you can see at the end of the first tick, both sample and holds have 0. And that's because we're starting from nothing. So then we're going to step again. And you can see now our first one has 100 because its gate is open. And we are taking the inverse of our second sample and hold. So our second sample hold is still 0 because there was nothing for it to sample on the first tick. So we take that, we flip that, and that's what we store in the first. So we'll keep that one there. That keeps going because the gate in our second sample hold is now closed. So we keep that for 3 ticks. Now here's the interesting one, where now we're sampling again, and we're sampling the output of the first sample and hold, which is 100. We sample that, that's going to become our new output. We flip that to 0, that's what we're going to return back. And that's that. And so these two will switch spots every time we have that clock 4 pulse. And by inverting the output and using that, we can keep track of, because we start at 0, so we invert it to start at 100, and by keeping track of that, we get our correct out 1 signal. It's a little confusing, and if I'm struggling to explain it very well, but hopefully you can kind of see what it's doing. I think this combination of 2 sample and holds is really confusing as to how that logic works out. I don't really like it. I'm hoping, since this is a bonus mission, that we won't run into that again. So all that said, we finally have our out 1 signal. So with that, we can now look towards our out 2 signal. So let's go ahead and stop that. Our out 2 signal, we actually built this way back at the beginning 2, maybe 3 episodes ago. Because this one's very simple. We have an interval clock 2 and an interval clock 3. And all we need to do is switch between them based on our out 1. Now that we finally have our out 1, I think we can just plug this guy in here and plug this guy in here. Now we might have to switch this knot to be for the first VCA. I don't 100%, I'm not entirely sure, but that should be it. And then we can send that to out 2 and let's see what happens. Yeah, let's crank it up. And there you have it. Finally, at last, tractor gear system complete. Whew. Hopefully, since that was actually like the second bonus mission in a row from where we're at kind of in the main story, hopefully this will be one of the harder missions we come across. If we jump back, probably have a little bit of dialogue here. Nice work, you just did my job for me. I will send you an invoice. You owe me all the money. Huh. How did the monetary system work in the old world? Who knows? It's a complete mystery. We were supposed to switch to a thing called Bitcoin, at least according to people like Ellis, but of course the whole civilization collapse thing put an end to that. Huh. Interesting. So not only is this post-apocalypse, this is apparently so far post-apocalypse that nobody remembers how the world used to work. Interesting. Anyway, all right, so back here at level select, let's see, how far are we? 3, 6, 9, 18, 21, we're on our mission 22, which I think is almost halfway done. For some reason, I have it in my head that there's 46 missions. I don't remember where I read that, but let's keep on moving now that we finally have a new puzzle to tackle. Drone Pathfinder, here we go. You've been doing good work so far. Most of the basic systems are up and running. From here, things will start to get more complicated. Hey, I say I have a hard time believing it's more complicated than that last one. That may come back to bite me. I'm ready for it. Excellent. We'll start with the harvester drones, one of the more sophisticated Ellis Agritech machines. No more manual harvesting. What do I need to do? We'll start with the pathfinding circuit in the drone. It takes data from the environment and finds the most efficient path to take. We've sent you a new module, the signal delay. Use it to add a time delay to a signal. You'll need a time delay to do numerical comparisons in the circuit. Alright. Okay. Drone Pathfinder. For each time step, compare the current signal at source 1 with the highest value, with the previous 2 values. Send the highest value of the 3 to out 1. If there is no previous value, assume the previous value is 0. Okay, that doesn't seem too bad. And we have the new signal delay. Sends the input to the output, but delayed by a specified number of time steps. Ooh, fancy. Okay, so this should be pretty simple, right? We just do a split. And then we want 2 signal delays, right? Delay by 1 and delay by 2. And so across all 3 of those, in fact, let's throw an oscilloscope on here just to confirm. Well, let's do it this way. Out 1 is going to be the current, so starting at time step 2, out 1 is going to be the current time step. Out 2 goes through a 1-step signal delay, so this is going to be, well, current plus 1. Or current minus 1. And then out 3 is going to be current minus 2. Right? So let's just start there. And make sure that looks right. So what we would expect to see here is we'll expect to see our standard output signal, so our standard source 1, on this first line. We'll see the exact same line on the second line, but delayed by 1. So where this will be, I guess this value, the second value will be the same as the first value, the third will be the same as the second, etc. And then this line should be the exact same thing, but delayed 1 more. Let's see what we get. Let's try that again. The same on all, so that's 0. Oh, okay, so 14 is the first time step. 0, 0. So now we should expect to see a 14. We'll see what? 19 here, 14 and 0. Yep. And then 16, 19, 14. Yep. Excellent. That is exactly what we want. Okay. So now all I need to do is we're going to take, let's get rid of that. We're going to do max. We need 2 maxes. We're going to do the max of 1 and 2. And then we'll take the max of that and 3 and send that to 1. And that should be it. That's a beat. Yeah! Excellent work. Thank you. Take a look at your farm now. Look at the progress you've made. Let's look out our window. Okay. What do you think? Now that you mentioned it, yeah, it's changed a lot. Has it though? I guess this was like not green before. Yes, and it will continue changing. Things decay, we build them up again. Alright, that was not bad at all. Keep going. Drone processor. Alright, time to continue work on the harvester drones. Their main processor board is still fried. What do I have to do? We can start with the accumulator circuit. It's necessary for it to do arithmetic computations. Careful though, it's a tricky circuit to fix. Let's do it. Alright. Build an accumulator that counts starting from 0 volts and increases by 1 volt for each time step, and send it to out 1. Tip: signal delays can be used to build feedback loops. Okay. What's my input signal? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So... oh, wait. Oh, that's my out. Oh, I need a generator. Clock. The lowest a clock can go is interval 2. That's interesting. Let's run our clock through a delay. And let's just see what that does first. 0, 100. 0, 100, 0, 100. That's not what I want. Okay. What's the range on this? Positive 100 to minus 100. So we can do minus 99 to get a voltage of 1. This is an optional module. It is recommended only for advanced engineers experimenting with alternative circuits. This is an optional module, isn't it? Interesting. So that tells me, theoretically, we should not need sample and hold, we should not need clock, and we should not need and or not. Can I was hoping there was a way to hide the optional ones. That tells me that the trivial answer here can be done with the signal delay and a bias. And that's it? How do I do this without a clock? Well, no, even the not is optional. Oh, okay. Okay, no, actually this makes sense. The bias works this way, right? It says the bias outputs... Oops, did not mean to do that. So it says the bias outputs the offset. If there is no input, the bias outputs the offset value. So if we set a bias to 1, then it'll just output 1 volt every tick. So then we can sum with a signal delay. Wait a minute. Will that work? So what will this do? This will output 1 volt every tick. We're going to take the sum of a delay, which after the first step will be 0. So it should be 0 plus 1. We'll send that here. We will throw the 1 into the signal delay to be returned next time and output the 1. Then on the second set, it will output a bias of 1. The signal delay should give us the 1 from the previous loop. This is really what we wanted in that last one. It'll give us the 1 from the previous loop, and this should sum to 2, store the 2 for next signal, and then output the 2. Let's see how we did. No, not at all, not even close. So first of all, we started with 1 instead of 0. Oh, that's the only problem. We started with 1 instead of 0. Otherwise, you can see it, the numbers in the red there. It is working. We just started with 1 instead of 0. So how do we start with 0? Takes an input and shifts it by a constant offset value. I got it. Let's have a second bias, starting at -1. That's not going to work at all. What am I talking about? Right, that won't work. If we do this, it'll start with -1, and this will just always output -1. And so this will add 1 to that, which will always be 0. And then this will always be 0. So that's absolutely not right. The bias modifies the amount by 1. So what if instead of using this as a generator, what if we did this the other way around? Hold on. What if we did the signal delay first? To the splitter. Output the result of the signal delay. And also add 1 to it. And pipe that into the next cycle. So first cycle, signal delay has nothing in it. So it'll return 0. 0 goes here. We're going to output 0, which is what we need to start with. And we're going to send 0 to the bias. We're going to increase it by 1. So now it's 1. Send that 1 to the signal delay to be returned to the next step. Next step, we return 1. Return 1 out. And send it to the bias to increase it by 1 to loop. Oh, that's nice. Look at that. Perfect. 18,000. Excellent work. Feedback loops like these are quite important to a lot of complex circuits. No doubt you'll be seeing more of them. Got it. All right. Let's see. We are at 24 minutes. I think we got time for one more, hopefully. Let's give it a shot. Let's see if we can squeeze it in. Radar system. Hey, one of our scout drones has detected movement near your farm. A group of people from the looks of it. You need to be on alert. I told you, Miriam, we've just put our friend's life in danger. Enough, we don't know who they are yet. So what do? The radio broadcast system has a secondary function. It can be used as a radar system. Time to activate that function. It'll help you track the group's movements and prepare to respond to them accordingly. Okay. Concerning. Alright. Emit a decaying signal to out 1 whenever source 1 outputs 100 volts. The decaying signal reduces by a fixed value at each time step until it reaches 0 volts. This fixed value will range from 0 to 36 volts. Source 2 specifies the fixed value. Oh. Okay. So we need a VCA. And the CV of the VCA is driven by source 1. And that goes to out. Now, so in this first example, source 2 outputs 28. So we want to output 100 minus 28 every tick. So we're going to need feedback loop. Signal delay is going to be max of previous step. Where is... I don't think I want... Takes an input and reduces its intensity. I don't think that's what I want. I want bias, but not with a constant offset. Can I use another VCA for this? Hold on. Let's get rid of that. We know how to trigger that. Let's figure out how to get this decaying signal. So we clearly need a feedback loop that reduces by a percentage every time. So it's almost like we need... I think we want to send the decayed signal into the CV. Right? So on time step 7 here, we want to output 100% of 100. Here we want to output 72% of 100, 44% of 100, etc. So the in for the VCA should always be 100. And we can do that. Do we have to do anything, or will it just always? No. Okay. So we are gonna do a not. It calls this an optional module. I don't. There. Yeah. So this will just always output 100%. So now we want to set the VCA to be a decreasing percentage. So we want to set the signal delay to the max of the previous step and out 1. That's how we'll get like this scenario where the signal's decaying, and then it just renews up because a new tick came in and we just start over. So then how do we make the decay? We'll take the previous time step. We have to send to the output before we do the signal delay. Because if we do it after, then our output's going to be offset by 1 from the input, but we need it to take effect on the input. So I think we're actually going to need the max to happen after the signal delay. Take source 1, subtract, we need a gate and hold, sample and hold, and a splitter. Okay, so whenever we come into here, we want to open the gate, Source 2 is going to be what we sample so that we hold it for the duration. And then we want to output, or into the signal delay, we want to reduce, we want to say, what do we want to say? We want to say the previous output. So let's do a, we don't have a subtract. You can use the attenuator to subtract, right? Minus 100% inverts the signal. So if we get 28, for instance, this will make that negative 28. And then we can sum that with the max of source 1 and the previous step. Wait. I'll take the max of source 1 and the previous step. So if the previous step is 58 and the current step is 100, we're going to take 100. Give me a split. We'll send that to out 1 and subtract the source 2 amount from it, and then store that in the signal delay for the next cycle. And this doesn't go here, this goes here. Is that right? No, I'm doing the same thing twice here. This subtraction that's happening here and this VCA are doing the same thing. Okay, let's try that. Not too shabby. I'm a little amazed that one worked on the first pass. I was expecting to have to mess with it a bit more. Good job. Looks like the group is still quite far away from you. You can continue your work, but keep watch on the radar. All right. Excellent. Well, that, I think, is a pretty good place to... Oh my god. 5 new optional missions? This is going to be the death of me. Well, we will pick up with the drone accumulator optimization and other associated optional missions next time. If you guys are enjoying this, hit that like button, leave a comment, let me know. Love getting your feedback. And if you're not enjoying this, I'd rather move on to something else. I'm enjoying it, but I produce these videos for you. Let me know. So with that, I want to thank you all for watching, and I will see you next time.